Hello, Algebra 2 students. Today we will be doing 8.1 notes, model, inverse, and joint variation. In Chapter 2, Section 5, we explored direct variation. Direct variation is modeled by the equation y equals, this was our ax equation that I mentioned back in Chapter 2. And we say that y varies directly with the variable x. The non-zero constant a was known as the constant of variation. Notice direct variation is a linear equation such that the y-intercept will always be 0, 0. Graph the examples of direct variation and determine the constant of variation. First, we can go ahead and determine the constant. So the constant is the value right in front of x. So in this case, the constant of variation, a, is negative 1/2. And remember, that means go down 1, right 2 to help you graph. Always start at 0, 0, because that's your y-intercept. So go down 1, 2 to the right, down 1, 2 to the right, and so on. And then from the opposite side, you can go up 2 and 2 to the left. Opposite, or from the y-intercept going the other direction. So up 1, 2 to the left. And you don't have to dial or plot all the points. So up 1. Just draw enough that where you can kind of see the equation. And then connect the dots with a smooth line, or with a straight line, sorry. And then our next one, I don't know why this is so slow to move. Won't move. All right, this might be a little tricky to try and get the thing to move. So the next one is y over x equals 5. So we want to solve for y. So we're going to multiply, or we're just going to cross multiply. Remember, that's just over 1. So we have y equals 5x. Our constant of variation is 5. Just write it as a fraction to help you graph. 5 over 1. So up 5, 1 to the right, or down 5, 1 to the left. So start at 0, 0. Go up 5, 1, 2, 3, 4, 5, 1 to the right. Repeat. Other direction, go down 5, 1 to the left. And then connect. Always noticing that it goes through 0, 0. Here we go. There are many real-world applications that model direct variation. For instance, we can say that the distance d varies directly with time t at a constant rate r, giving us the dirt formula, where d varies directly with t and the constant of variation would be r. We could list a simpler example, such as the more you study, the better grade you will get. Since both studying and grades are increasing, this models a direct variation. Now, in Chapter 8, Section 1, we are going to look at what is known as inverse variation. We say that two variables, x and y, show inverse variation if they can be modeled by the following equation. So y equals ax, the ax equation is direct variation. Inverse variation has the following equation, y equals a over x. Where a cannot equal 0. The non-zero constant a is still called the constant of variation. We can say that y varies inversely with x because as one variable increases, the other variable decreases. The equation y equals a over x can be solved for a for an equivalent statement. So if you were to solve for a and cross multiply, you get xy equals a. Okay, the graph of an inverse variation equation is the shape of a rational equation where the variable is in the denominator. And you see that y equals a over x, the variable is in the denominator. And on the left side, you see what a graph looks like. Now we are going to graph a simple equation, and it's y equals 2 over x. Make a table of positive and negative x values, but remember you can't make 0 because 2 divided by 0 doesn't exist. So if we're supposed to make a table here, and so let's pick pretty decent numbers because 2 divided by, we want to pick even numbers. So let's pick -4, -2, -1, +1, +2, +4. So let's start with -4. 2 divided by -4 is -1/2. 2 divided by -2 is -1. 2 divided by -1 is -2. 2 divided by 1 is 2. 2 divided by 2 is 1. And 2 divided by 4 is 1/2. And now we can plot it. The thing we need to know is we do have asymptotes. We have 2 of them, and we need to plot them in. So we have this one. So draw in your asymptotes so as to not cross either of those lines. And then we're going to plot our points. So we have -4, -1/2. Right here. Oops, kind of made it not too pretty. -2, -1. -1, -2. And that's enough to show the curve. So it goes this way, gets closer and closer to the red line that way, and gets closer and closer to the red line this way. Oops, without going over. Sorry. Kind of went over. Kind of touched it, but it'll be okay. And then here we have 1, 2, 2, 1, 4, 1/2. Try to make this line a little bit nicer looking. There. And that is a graph of a rational equation. An example of inverse variation in real life is the length of a rectangle varies inversely with its width W given a constant area A. This gives us the equation L. So the length varies inversely with the width. And the way I read it, length varies inversely with width. Width would be in the denominator right there. A simpler example is the more you slack off, so that variable is increasing, the worse grade you will get. You get a lower grade. And finally, we are also looking at joint variation, which extends direct variation to get the following. Z varies jointly with X and Y, given that, and notice how something is stated, that's how you start your equation. So Z varies jointly. So Z is going to be on the left side. Jointly means there's going to be more than one variable. In this case, the variables are X and Y. So they're going to be on the opposite side of the equal sign, and the constant goes in front. And you could also do something like this. P varies jointly with Q, R, and S. And A is your constant again. Don't ever forget your constant of variation in direct, inverse, and joint variation equations. So we are going to classify each equation as direct variation, inverse variation, joint variation, or none. And the thing to do is solve for y in each of the cases. So here we're going to divide by x. So we get y equals 7 over x. This is an example of what is known as the inverse variation, because notice y on the left side, but x in the denominator on the opposite side. This is an inverse variation. You can't just look at an equation and just tell which one it is. So you do need to solve for the variable. Y here is already solved for. This would be an example of neither. And the reason why is it could have been a direct variation had there not been a 3. But you can't have a y-intercept of 3. And we could say the y-intercept is 3. The next one, we want to cross multiply. This is an example of a direct variation, and the reason why is the y-intercept is 0, 0, 4x plus 0. Not that you have to tell, but if you had to. And the last one, notice you have more than one variable on the right side, and you have the constant in front, so this is joint variation. Hopefully these notes have not been that painful. All right, now let's go to the back portion. Write an inverse. How do we write these? So write an inverse variation equation or joint variation equation. The variables x and y vary inversely. So let's read this very carefully. So variables x and y vary inversely, and y equals 7 when x equals 4. So it's already telling you the key word here is inversely. So y equals, so write your inverse variation equation. It's the first thing you do. So that's what I did. Now you're going to plug in y equals 7 when x equals 4. So this is important. It's given to you. Here, I'll just bubble it. So y equals 7 when x equals 4. So your whole goal is to figure out what a is. Cross multiply. 7 times 4 is 28. What do you do with that a? Well, all you do is you replace it back into your equation. So your equation is y equals 28 over x. You're not supposed to replace the 7 and 4 again because you want to show the relationship, because it says right there, write an equation that relates x and y. So this is your equation. So the steps are solve for a first. Next step, plug in a. Plug only a back into your equation. Right? And, oh, we have one last thing. It says, then find y when x equals -2. Okay, so we are going to use our boxed answer. So we have y equals 28 divided by -2. So y equals -14. So two parts. Part 1 was getting the inverse variation equation, and part 2 was figuring out what y is when x is a certain number. Okay, next problem. The variables x and y vary inversely. So again, so let's write our equation. Y equals a over x. The point 1/2, 12 is on that particular curve, the one that we graphed, but that's a different equation. So remember, a point is always x, y. So it's basically the same as problem number 1, but in number 1, I bubbled in y equals 7, x equals 4 because they were given as separate numbers. It's the same thing. So you're going to replace y with 12 and x with 1/2. Then you're going to cross multiply. You're going to multiply 12 times 1/2. Equals a. So that's 12 divided by 2, so it's 6. A is 6. I'm going to put a star by it. Should have done it here because the star tells you, hey, you have to do something with it. You're going to plug it back there. So you get y equals 6 over x. That is your equation. That is your inverse variation equation. Now let's do part 2. Find y when x equals 2. So y equals 6 divided by 2. Y equals 3. It's not too bad. Just know your equations. Ax equation is direct variation, y equals a times x. Inverse is y equals a over x. And joint is just multiple variables on the right side. All right, next one, number 3. The variable z varies jointly. So keyword here, jointly. Start with your variable z here and put in your constant of variation immediately after the equal sign, because that's how joint variation is written, and it varies jointly with these two variables. Also, z equals -75 when x equals 3 and y equals -5. Notice we don't know a. That is the crucial step here. So -75 equals 3 times -5 is -15 times a. Divide by -15. And a equals a +5. Star it and then draw an arrow saying you're going to replace it. So our equation, our joint variation equation is z equals 5 times x times y. Now, let's find z when x equals 2 and y equals 6. And you can multiply in any order you want. That's 5 times 2 times 6, so 10 times 6, 60. Here we go. Right. The driving distance between two specific locations varies inversely with the average driving speed. The driving distances between Chicago and Minneapolis is about 400 miles. So here we said varies inversely. So as one increases, the other decreases. So as driving speed increases, the driving time decreases. Write a model that gives the driving time t in hours, not including stops, between Chicago and Minneapolis as a function of average driving speed r in miles per hour. So let's take our DIRT formula, distance equals rate times time. And we want to solve for t, write a model. So we want to divide both sides by r. So r's cancel, and we get t is equal to d divided by r. So here's our equation. The time is equal to the distance divided by the rate of speed. Make a table showing the driving time for average driving speeds of 32 miles per hour, 40 miles per hour, 50 miles per hour, and 60 miles per hour. So we are going to put here speed, and speed, remember, is our rate, and here time, t. So we want to make a table for 32 miles per hour, 40 miles per hour, 50 miles per hour, and 60 miles per hour. So let's plug in each of these numbers into our equation. So t equals 400, because 400 is our distance. That's the distance between Chicago and Minneapolis, divided by 32. So that, when you divide it, you get 12.5 hours. Next one is going to be 400 divided by 40. That's easy to divide. 40 divided by 4 is 10, so that takes 10 hours. Next one, 400 divided by 50. Cross your zeros out. 40 divided by 5 is 8. And last one, 400 miles divided by 60 miles per hour. 40 divided by 6 is going to be 6.6 repeating. So 6 2/3 hour. And that is a real life example of an inverse variation equation. Next one. Or I'm sorry, for yes. As one increases, the other decreases. Write an equation for each relationship. Y varies inversely with the square of x. So I'm going to box in keywords. And notice the number 1 begins with y. So you would say y. When it says varies inversely, immediately put an equal sign. And when it's inverse, remember your constant goes on top and your variable goes in the bottom. And the variable is going to be the square of x. So that'd be x squared. Okay. Next one, number 2. X varies jointly. So x varies jointly. So immediately put the equal sign and the constant variation. With what variables does it vary jointly with? T and R. Okay. And, however, inversely with S. So S goes in the denominator. So X equals A times T times R divided by S. I wrote really big, but that's okay because I'm going to do 3 and 4 over here on the bottom. Okay, number 3. P varies jointly with Q, R, and S. Q, R, S. And inversely with the cube of T. So cube of t doesn't mean 3 times t, it means t to the third power. Okay. And our last one, number 4. X varies directly. Here's a direct variation. With y. So direct means all on one line. Inversely with z. And that is the equation for number 4. And those are your notes for today. Have a great day, Algebra 2 students.